Hello YouTube and welcome to another Cisco tutorial. So in this video I'm gonna show you how to protect your Cisco devices against HSRP attacks. So are you ready? Let's get started. So first thing first, what is HSRP? So actually HSRP stands for Hot Standby Router Protocol. Okay, so actually it belongs to a family of protocols that we call First Hop Redundancy Protocols. Okay, like for example FHRP or GLBP. Okay, so all those are actually First Hop Redundancy Protocols, but HSRP was actually implemented by Cisco. Okay, so what is actually it provides actually a mechanism for router and switches to establish a fault-tolerant default gateway. Okay, so here as you can see in my Genesis 3 lab, okay, here we have actually, as you can see here, a client, for example a PC1 that want to reach PC2. Okay, so normally on this client we configure a default gateway, and this default gateway can be either router 1 or router 2. Okay, and this actually default gateway is a fixed IP address. Okay, so if one of those routers fail, we cannot have connectivity to PC2. So in order to solve this problem, we create actually a virtual router with the virtual IP address, as you can see here, for example 10.1.1.1. so this is just a virtual actually IP. Okay, and we configure our client to use this default gateway. Okay, and in case for example router 1 fails, this IP address, this virtual IP address still exists in router 2. Okay, and this mechanism is automatic. So if you configure actually this virtual IP on router 1 or router 2, either of these two routers which actually belong to a group can actually implement this IP address. So as I told you, we configure it in router 1 and router 2, and those routers belong to a group, but one router is always active and another one is standby router. So standby router is just a backup router, and active router is responsible for forwarding traffic. Okay, so let me show you here the configuration, for example for router 1. So I will go here to I will just click on router 1. Okay, here we go. So in order to see the configuration, show running and on the interface, but let me just show you the IP addresses. Show IP interface brief for router 1. Here I forget a space. So as you can see here, we have Giga Ethernet 0/0. Okay, and in this interface here we configure this IP address. Okay, 1.1.1.3. so let's see the configuration of HSRP on this interface. So it's pretty simple. Show running configuration on interface Giga 0/0. Here we go. So the simple command that we use is this one, standby, and actually a number for the group. As I told you, each router belongs to a group. Here we name that group 1, and we provide the virtual actually IP address for the virtual router. So in this case is that 10.1.1.1. Okay, simple as that. Okay, so if I go to, for example, router 2, as you can see here, and we do the same thing, show running configuration on the same interface. You got 0/0. Normally you will see the same configuration. So as you can see here, standby 1 for the group name, and we implement the IP address 10.1.1.1. so this is our virtual IP address. Okay, and in order to see which router is active and which one is standby, we can do this command in any router that belongs to this group. Show standby detail, or brief actually. Here we go. So we are on router 1, and as you can see here for the group 1, here I have configured 2 group, but let's just focus on the group 1. So for the group 1, the active router is the local one, because now I'm on router 1, so router 1 is active. And standby here, it gives me the IP address 10.1.1.2, which is actually the IP address of router 2. So in this configuration, router 1 is active and the router 2 is the standby router. And as you can see here, we have the virtual IP for the virtual router is of course 10.1.1.1. okay, so with this configuration actually we provide automatic fault-tolerant default gateway, okay, for the client PC1 for example. So whenever router 1 fails, automatically router 2 will take precedence and will forward the traffic in the place of router 1. So this is actually the utility of HSRP. But actually in order to explain the vulnerabilities protocol, so these two routers exchange actually information via what we call hello messages. So it's actually multicast messages via the address 224.0.0.2, okay, on port UDP 1985, okay, and this hello messages which cause problem, okay. So here I will show you just a capture of Wireshark so you can see actually this HSRP hello message. So as you can see here, the IP address for the multicast is 224.0.0.2 and the UDP port is 1985, and authentication that is used is actually just Cisco. So this is the weakness of this actually protocol, and we can actually use tools in order to become a man on the middle. So how can we do that? So simply we can use tools to allow us to be the active router, is simply as that. Because actually in order to be an active router there is an election process, okay, based on the priority, okay, priority plus the IP address. But the most important parameter, as you can see here in this Wireshark, is the priority. So by default it's 100, but if we inject in our topology or our network message with the higher priority, the sending message station will become the active router and therefore will be actually the man of the middle and can be the active router. So this is how I'm gonna show you to do using a famous tool called Yersinia. So you have previously seen that tool on my previous video, and once again it's a disclaimer, don't use that against anyone's Cisco device. Use it in your own actually devices for educational purposes. So let me move on to my Kali Linux and see how we can actually implement this attack. So here I'll go to my Kali Linux. Here we go. So this is my attacker. Let's say this station here. Okay, and we'll be using, actually, as I told you, Yersinia in order to attack or to implement this man on the middle attack. So I'll use Yersinia in the graphical user interface. So this is it. Here we go. So you can see this tool can implement attacks on different protocols. Okay, so the protocol that we are interested in is HSRP. So I'll click on it, and you see it has detected actually our routers. Okay, so 10.1.1.3 is the first router, router 1, and 10.1.1.2 is the second router. So you can see here the multicast address. Okay, and in order to implement this attack, it's simple as doing or launching attack here. So click on this button, and it gives me this window, so we can become an active router, for example. So let's click on this radio button here in order to become an active router. So we click on OK, and here it's giving me the source IP address of the active router, actually the station that will be the active router and therefore will be the man in the middle. Okay, so I can give whatever station that I want to be the active router. So this is the vulnerability actually. So we can, for example, 22.22.22.22. okay, so if you have a router and you want it to be the active router, you can do that very easily with this tool. So let's launch this attack, and let's go actually now to our router and see the configuration to see if indeed 22.22.22.12 becomes the active router. So here you see a couple of messages. So before here on router 1, the active was router 1, as you can see here in this line. Let's do the same command and see now who is the active router. Show standby router 2, standby brief, sorry. So as you can see here, the active router now is the station that we have implemented. So it's 22.22.22.12.12. So it's became actually the active router, and router 1 is no more the active router, it's became a standby router. Okay, and we still have the same virtual IP address. So with this attack, we can be, or any station can be actually the active router and can actually see all the traffic that goes through it, because as I told you, the active router is the one responsible for forwarding the attack. Okay, and standby is just a backup router. So you can configure your station or any router to be the active router with this simple tool. Okay, so this is the vulnerability, but now how can we actually prevent that? Okay. So in order to prevent this kind of attack, we implement authentication. So as you saw previously, the authentication used for this protocol is simple as Cisco, but we can actually provide our own authentication using MD5 key string. So as you can see here, I have configured key string called, for example, here passwords for authentication. Okay, so with this method you can be sure that your protocol will actually not using the default authentication Cisco. Okay, you can of course use also an access control list in order to prevent this kind of attack. Okay, so you configure an access control list for just the router that you want to receive the hello messages, and that also could prevent this kind of attack. Okay, So don't use the default authentication used, which is Cisco. Okay, so that was just a brief introduction to this pretty actually useful protocol called HSRP. As always, I hope it has been informative for you, and I want to thank you for viewing. Bye bye.